So for example 4a, to state the upper sum and the lower sum using sigma notation, we want to first of all check if the function given to us is a continuous function with a monotonic property. Monotonic property means that your function is either increasing or decreasing. So the slope maintains either positive or negative. Now you can use derivative to check for increasing or decreasing function, or you can quickly look at this graph and see if the lines will give us an increasing slope or decreasing slope. So for example 4a, to check whether the left sum will give us the upper sum or the lower sum, I can draw this out. And since we want to look at the function from 1 to infinity, I will have the x value, well, focusing on the positive value. Well, from 1 to infinity, I will use -1 to +10. And as I graph it, I can see how this line will continue to drop from this point all the way, and well, you can hardly tell if the slope at the end will give us a decreasing slope or not. So maybe the best way to check is to take the derivative. So in this case, if I have f of x equals e to the negative x squared, differentiating this function using chain rule will give us negative 2x as well. And for x bigger than 1, this guarantee will give us a positive value. It just gives us something that is small, but definitely positive. And inside the bracket, with a -2 inside the bracket, this part will definitely give us a negative value for all x value bigger than 1. So guarantee that as f prime of x is less than 0 for anything bigger than 1, for x value bigger than 1, we can then conclude that this is a decreasing function. And for a decreasing function, we can then use the sigma notation here to state the upper sum and the lower sum. The upper sum happens, or the maximum sum happens, when you are using a left and Riemann sum. Because for x equals 1, starting on the left hand side, creating your rectangle here, the left hand sum will continue to overestimate the function. So it is the left hand sum that will give us the maximum value. And that means the right hand sum will give us the lower estimated value. So altogether, sigma notation for this would then be this for function of that less than the integration from x equals 1 to infinity for the function here, and it will be less than the left hand sum, k equals 1 for k equals 1 up to infinity e to the negative k squared. So that will be the lower sum and the upper sum, the estimate, using the Riemann sum estimate. And going back to example 4b, using the same concept, if you are looking for an estimated value using sigma notation, starting from x equals 10, which is somewhere down the road for x value, seeing how this line is increasing from this point all the way to the end, you will be using this definition here, which involves this and that. So technically, I should have this part as k squared, and this part will be k k squared as well. So starting from k equals 10 all the way up to infinity, with the right end, the other sum, the maximum sum will start from k equals 11 up to infinity.